Alright. So, Chris, do you remember what did we learn in the last class? Not Chris, Dave.
Yeah, I
Here comes
kind of
Chris.
forgot what we learned.
We learned matrices. We started learning about matrices. Hey, Chris.
Hi, sir.
How are you?
I'm good. How are you?
Good. Just reached back home from work and I thought, let's learn something. So I was asking Dave to tell me what did we learn in the last class. So we had started learning unit 7, which is about matrices. So when we talk about matrices, it's nothing but array of information that is written in this form. It's like a two-dimensional form. It could be, let me not say two-dimensional, let's say so this is a 2 by 3 matrix, correct? That's what you would have learned. And then we talked about this is a 2 by 2 matrix, which means 2 rows and 2 columns. This is 2 rows, 3 columns, so it's 2 by 3, it's 2 by 2. So then we learned about what do we mean by multiplying a matrix with a scalar. So if you have, let's say, a matrix called A equal to this, if you have to find out 3A will be how much, what you will do is eventually you will multiply each and every term of the matrix with this number 3. So this becomes 3 into 3, this is your first term, then 3 into 4, that becomes your second term, 3 into 8 becomes your third one, and you go on that way, right? So this, yes, Chris.
So, suppose you were multiplying two matrices together. So would you just multiply each element with the other?
So we have not come to that yet.
Oh, okay.
So multiplication of matrix, we are not talking about multiplying a matrix with another matrix. We are talking about multiplying a matrix with a scalar quantity, be it 5, be it 8, be it 10, right? So these are scalar quantities with which we are trying to multiply the matrix. So when you say, if let's say your matrix is let's say if you have a matrix A which is okay, so now you guys first tell me what is the dimension of this matrix.
4 by 2.
4 by 2. So that part is clear, right? Now we know, okay, how do I recognize the matrix based on its dimension? Now somebody says A is this, what will be 2A? So if you look at matrix doesn't have its own identity. It's known by its elements, okay? And these are elements which makes this matrix. So when you are talking about 2 times of A or 2 times of the matrix, you are essentially talking about every element gets multiplied by 2. If I say 3A, I am multiplying every element of the matrix by 3, and that becomes my resulting matrix. If somebody says minus 6A, if this is A, minus 6A means it is multiplied by minus 6. And when it is multiplied by minus 6, that means we are not looking at A as an individual entity. It is made of these elements. So when you are multiplying A by this, that essentially means you are multiplying each and every element by that value. Yeah?
Yes, sir.
Now, the next thing that we learned was how do we add two matrices. So, I'm not sure if I'm pronouncing it right or not. Let's see if I'm adding these two matrices. This is my one matrix, and second matrix is this. If I'm trying to add them, same thing applies here also. This poor guy doesn't have its own identity. This guy has identity neither. They are known by the elements. So when you're talking about A plus B, you're talking about adding the elements of these two matrices, and then what you have to be careful is same matrix and the elements in the same position gets added, meaning first row, first column element gets added with first row, first column element of this one. First row, second column element gets added with first row, second column. Second row, first column element gets added with second row, first column of the second matrix. Second row, second column element gets added with second row, second column element of the second matrix. So, if you are adding any matrix or if you are subtracting any matrix, what this means is you are dealing with the elements at in the same position, same row number, same column number, and that they deal with them respectively. This is what we learned in the previous class. Are we clear about this? Yes, Dave.
Sir, I kind of forgot, but if the matrix aren't the same dimensions, we can't do anything with them, right?
Yes, you cannot. So that's what I'm coming to. So see, when I'm talking about adding the two matrices, what we are saying is I will add them, meaning I will add the elements in the same position. First row, first column, first row, first column. Second row, first row, second column, first row, second column. Second row, first column, second row, first column. Second row, second column, second row, second column. That essentially means that if I am talking about if I'm talking about dealing with these two matrices, they have no way to deal with it. Like if I'm adding one apple with one apple, it becomes two apple. 4 apple with 3 apple becomes 7 apple. But 4 apple plus 2 banana doesn't mean anything to us. So is the case here. This is apple, this is probably watermelon. You cannot deal with them together. I mean, you can make smoothies, but it will not be apple smoothie or watermelon smoothie. It will be a mix of that. So here in mathematical terms, if you have two matrices with different dimensions, give it up. Say that this is undefined. I cannot deal with them. That's the premise that we have to always keep in mind. That if I'm talking about operations with two matrices, they have to be similar or they have to be matching when it comes to the dimensions both have. So this answers your question, Dave, which we talked about briefly in the previous class also. That if I'm talking about adding or subtracting a matrix, I'm simply talking about adding or subtracting the elements in the same position. Now here you cannot cover all the elements if you have to match them with the same position, right? Here first matrix has only 2 rows, 2 columns. This guy has 3 columns, meaning what will happen to this guy and this guy. So you're not getting to a conclusive point. That is why it is called undefined. Yeah? Make sense, Chris, Dave?
Yes, sir. Thank you.
Yeah. So that's what we'll keep in mind. That okay, if anybody talks about adding or subtracting matrix, we are essentially talking about adding or subtracting the elements in that position, in the matching position, in both the matrix, and then that we'll be able to do only if both the matrix have same dimensions. Now, there is something called zero matrix. Zero matrix. What is zero matrix? Any idea? Now let's look at this matrix. Let's say this is a 1 by 2 matrix. And let's look at another matrix where when all the elements of a matrix is 0, that is called a zero matrix. Make sense? Chris, with me?
Yes, sir.
Okay. So, if I give you a riddle and say I have a matrix C which is 3 by 3. I want to convert this to a zero matrix. How will you do it? Yes, Dave.
Would we make like a new matrix and like multiply them by 0?
Yeah. So if I have matrix C, if I want to convert this to a zero matrix, first of all, we were just talking about it, right? If I have a matrix where each and every element has a value 0, no matter what the dimensions are. If every element of a matrix is having only 0 as a value, that is called zero matrix. Now whether it's a 1 by 1 matrix, 1 by 2 matrix, 2 by 1 matrix, 2 by 2 matrix, 2 by 8 matrix, 3 by 9 matrix, whatever it be the case, whatever be the dimension, if each and every element of the matrix is 0, that means it's a zero matrix. So if we have any matrix given to us and we have been asked to convert that to zero matrix, we know that by the property of multiplication of a matrix with a 0 or with a scalar, 0 into A, like let's say if it is C, if I am talking about 2C, I am essentially talking about multiplying each and every term of C with 2. So that will multiply everything by 2. But our end goal is to convert this to zero matrix without changing the dimension. Obviously, you cannot change the dimension of the matrix. We have to just convert all the elements to 0. And for that to happen, this is our way to do it. Yeah. So this is about the zero matrix. We'll talk about the property of zero matrix also. Let's learn one more concept called opposite matrix. Yes, Dave.
Oh, wait, so I had a question. Even if it's a zero matrix, does the dimension need to be the same as the matrix we're multiplying it by?
So far we have not touched upon multiplication of matrix, okay? But the other operations that we have talked about, be it addition or subtraction, same thing. The only see, you have to look at a matrix this way, that a matrix is nothing but an array of data, array of information. If I am saying A equal to 5, I have only one value stored here as A. When I am saying A is a matrix, I am saying that I have multiple elements stored inside the object called A. Right? It has 4 values here. Now, when you talk about two matrices, let's say, I might go a little deep into it and start blabbering about computer programming, but bear with me. Let's say this is a two-dimensional 2 by 2 matrix, 4, 8, 2, 7. And this one is, let's say 0, 0, 0, 0, 0, 0, and let's say for now we have matching dimensions. Okay, so as long as we have matching dimensions, if we have to add them or subtract them, that is perfectly fine. But that is perfectly fine because you have a matching value for each element. Meaning matching row number and column number. Okay, so you can deal with them. But if you think that, okay, can I add these two because 0 means nothing, I will wipe off, I will ignore this part. Actually, you cannot do it that way. The basic principle that we have to keep in mind is, first of all, they have to have matching number of elements. Now let's go a little deeper into it, okay, just to understand the relevance of it. First of all, why do we deal with this kind of a thing? This is your preparation towards higher studies, correct? Where some of us will, not me, some of you will become scientists, somebody will become engineer, somebody will become doctor, somebody will become lawyer, somebody will become something, based on which career you want to pursue. Now, let's say if you guys go towards the path that I followed, meaning go towards the IT industry. So if you think about the IT industry, think about computer programming. Let's not worry about the industry as such. Let's talk about the computer programming part of it. Now, all of you who have got exposed to programming, I'm sure you guys have better exposure than what I had at your age. So I'm sure you guys would have seen some form of programming where you will say, okay, there are variables, there are different placeholders, right? You'll say, okay, I have, if somebody has done a calculator program, you'll say, okay, calculator has a program written underneath where you can give two values, A as something, B as something, and then my program basically adds these two. So basically what happens is, there is a placeholder created for A with a data type. Say, okay, it's a numeric field. You cannot enter A, B, C, D here. It's a numeric field. So when you press a button, it puts a value in here. When you put B is again another placeholder created. That okay, this will take one input, this will take another input. And they are defined data types. Okay, you can only enter numbers here. And again, don't worry about it. I'm not trying to go deep into coding or programming. But what I'm saying is here is, the way this program works is, there are placeholders created. If this gives the ability to only add two numbers, it has two placeholders created. And it has only enough space to store one value and one value. When you expand it, make it more comprehensive, when you add more functionality into your program, you'll say, okay, fine. My calculator gives me ability to add four numbers. I can add four numbers together and add with a fifth one. So essentially, you are creating place for storing five values. So, and this can keep on expanding. So that is why when math kept on evolving to cater to different types of needs, people felt the need for expanding these variables to go beyond referring to only one number. Let's say if you have 50 students in a class, do you want to mention student 1, student 2, student 3, student 4, all the names, and then say how much marks everybody is getting? Next year these students will go to next class. What happens to the current class? There will be another 50 students who will come and join. So what the teacher does is, if you visualize this like a plan a teacher would have, they'll create 50 placeholders. This year we have Ram, Sham, Naresh, Suresh, Kareem, Rahim, Brandon, Charlie, all that, right? Next year, these are 50 placeholders created by the class teacher. Next year, after the one school year gets over, what the teacher will do? Flush out all the data, say, okay, fine, this year I have new students. I'll add the names in those places. So these arrays are nothing but, it's a group of data elements which are stored together, and it is structured in a way that it becomes easy that way. All are student information. I don't have to have 10 or 20 different names or placeholders where it becomes difficult for me to handle. Now, when somebody has to read this information, let's say this is a small class, it's only 6 students. If the teacher has to find out marks for first student, he'll say, okay, find me the data of B, first row, first column. He gets the marks for this guy. Let's say he has to find out the marks scored by this person. He'll say, okay, get me the data of B in the second row, second column. So that is how they locate it. So all that I was telling you so far was little biased towards computer programming, but don't worry about it that way. Think of array as an expanded form of data storage, where you're not storing one data in one place, you have the ability to store multiple data in the same place or with the same logical name. Okay, and it becomes easy for you to deal with them just by knowing or locating the place. Now coming back to your point there, where you were saying that even if I have a zero matrix, do I have to care about the dimension? Yes, you have to, because your basic principle remains the same. No matter whether it's a 0 matrix, 1 matrix, 5 matrix, 10 matrix. I mean, I'm just making it up. There is nothing called 1 matrix. But I'm saying, be it a 0 matrix or be it a matrix with some value higher than 0 or lower than 0. But your going in position is always the dimension. If the dimension is not same, you're not really going to care about the value underneath. You'll not even touch those things. Okay? I know it was a very long explanation for a very simple question, but I hope I was able to convey what I was wanting to convey. Chris, Dave, got tired?
No, sir, that makes sense.
Okay, all right. So basically that's one thing. Now when you talk about opposite matrix, what do we mean by that? Any idea?
Sir, can you repeat the question?
What do you mean by, let's say I have one metric A, let's say this is 2, 1, minus 3, 6. And another metric as B, 1, 8, minus 9, minus 2. If I say, find out the opposite of metric A, what comes to your mind?
Multiplying all the elements by -1.
Wonderful. Yeah. So, I mean, you are spot on with your answer actually, Chris. So here, it's like, what is opposite of positive? Negative. What is the opposite of negative? Positive. We'll use that understanding for finding out opposite of a metric. So if I have A, opposite of that will be minus A. If I have a B, the opposite of that will be minus B. And what would that essentially mean is, I am multiplying A by minus A. Or minus 1 times A, whatever you call it. So, if you have to find out the opposite of any matrix, it's very simple. Multiply that by -1. That is what will get you the matrix or resulting matrix. That is called opposite. Yes, Dave.
Sir, for example, if you had a matrix and we were doing like 2A, which is 2 multiplied by A, would the opposite matrix then be A over 2?
No. So here's the thing. So if, let's say this is my metric, 1 by 2 matrix. Okay. If I have to say 2A, I'm essentially talking about multiplying everything by 2. So this gets multiplied by 2, this gets multiplied by 2. Okay. If I'm saying opposite metric, I'm saying opposite of plus is minus, opposite of minus is plus. So here I have nothing, that means I have a plus. Opposite of that will be minus A. How do I get minus A? I get minus A by multiplying A by -1. So same thing I will do. If somebody says find out opposite of A, I will say this is opposite. I need to work on my spelling. You guys have opportunity to do spelling bee and all. I don't have that. My spelling is going for a toss. Okay. So if I'm talking the opposite of A, I'm talking about minus of A. That is essentially -1 of times A. That means whatever value I had for A, I'll multiply everything with -1. Everything with -1. And that is how I'll get the resulting matrix, which is the opposite of A. Yeah? So,
Thank you, sir.
So in simple terms, opposite of a matrix simply means multiply that by -1. As simple as that. If your matrix terms are negative, they will become positive. Whichever is positive will become negative, whichever is negative will become positive. But simplest, in the simplest form, zero matrix, I mean there are only two things that we have learned so far. One is zero matrix, where each and every term of the matrix is 0, and second one is called second one that we learned is opposite matrix, where you get a negative version of the matrix, meaning multiply that by -1 and whatever happens, happens. Yep. Alright, now let's look at some of the properties. So, let's look at, so whatever we will talk about, whatever we have talked about, it will be a summary of that. So let me just quickly look at what all I mentioned. Property of matrix, additions, subtractions, and properties of scalar matrix. Okay. So now let's look at the situation that we have seen. Okay. I'll put some matrix here. Let's say I have two matrices. Okay. B is 5, 9, and I have third matrix. So as soon as I do this, you guys have to stop me, saying, sir, you are wasting our time. If I have 3 matrices, only 2 of them have similar dimensions, third one doesn't. This guy is an outlier. I would not be able to do anything with this guy, even if you force me to. So please don't make me do anything with this guy if I have other 2 matrices like this. Okay? So that is where you will stop me, which will avoid wastage of time and effort. So as soon as you guys stop me, I'll say, okay, fine. I don't contradict. I don't like arguing with you guys, so I agreed to what you guys said. So these are the 3 matrices I have. So here are the properties. Okay, just look at them. If I say A plus B and B plus A, will they be the same, or there is a possibility where A plus B will not be equal to B plus A? So you guys know what do we mean by A plus B, right? We are adding the terms in the matching positions, right? So A plus B and B plus A. If I am doing A plus B or I am doing B plus A, both should be the same thing ideally, correct? Meaning, let's say, look at this situation, A and B here. When I say A plus B, what is the value of this matrix? This will be first term, first row, first column, 1 plus 5, I will add. 2 plus 9, first row, second column, I will add. What did I get? 6, 11. This is value of A plus B. Now let's look at B plus A. If I do B plus A, what will happen? First I will put the B terms, which is 5 plus 1, same position. I am not doing anything fancy, okay? I am just putting this number first because it's B plus A. 9 plus 2. What did we get? Same value. So B plus A gave me this matrix. The resulting matrix elements are same as what was the case in the first scenario. Agreed? Chris? Are you clear? I am saying A plus B or B plus A are both giving me the same answer, regardless of whatever value it has, right? The element, whatever value elements have, correct?
Yes, sir.
Now, so this becomes one of the property that you will keep with you, not because I'm asking you to memorize it, but this is a very simple interpretation that you can always have. Okay. Now let's look at this. If I say A plus B plus C and then say B plus C plus A, no matter, as long as the dimensions are matching, whether you are adding 1, 5, 5 or you are adding 5, 1, 5, your answer will be the same. Even if you have a negative sign or positive sign, that doesn't make any difference because adding them together doesn't change any of the signs. Your overall value will remain the same. This part is fine. So whether you're jumbling the matrices and adding one first, then second one, or you jumble them up, regardless whether you are dealing with two matrices or three matrices, it remains the same. Is it acceptable so far?
Yes, sir.
So basically, see, if you are adding two matrices, you will add these two terms. If you are adding three matrices, 1 plus 5 plus 5, 2 plus 9 plus 2. Same position, you will just add them. So the way we added two matrices, the same way we can add as many number of matrices as long as their dimensions remain the same. Okay? Now, life gets a little interesting. A minus B and B minus A. Will it be the same as well?
No.
No. As simple as that, right? I mean, I should not be asking this kind of stupid questions to grown-up kids like you guys. Right? 5 minus 2 is not same as 2 minus 5. As simple as that. Correct? And because when we are dealing with matrices, we are talking about addition or subtraction of elements. So addition doesn't make a change, subtraction does. A minus B and B minus A are not the same. Okay? So this one is not true. Same thing if you are dealing with A plus B minus C or C minus A plus B. Whatever jumbling you want to do, you will not really worry about the positioning of all those things. You can simply, with your bare eyes, you can look at it and you'll be able to make out that, okay, my dimensions are matching. You just pick up one sample and you will see that, okay, it's not the same. Even if I pick up this one, C minus A plus B. So first I have to get A plus B. A plus B is 6 and 11 and this is 5 and 2. C minus A plus B. 5 minus 6 gives me minus 1 and 2 minus 11 gives me minus 9. So minus 1 and minus 9 I got by doing this. Look at this, A plus B minus C. So you have 6 and 11 as A plus B. Now you are subtracting this. So 6 minus 5 gives you 1, 11 minus 2 gives you 9. These two matrices cannot be the same. 1 is not equal to minus 1, 9 is not equal to minus 9. So summary of that is, if I have matrices with matching dimensions, my addition has no sequencing issue, subtraction has. I cannot choose or I cannot jumble up the order and assume the subtraction value will be the same. Even if I have, let's say, I'm dealing with 5 matrices together, adding or subtracting them, even if there is one negative sign in between with respect to the operation you are trying to do, as soon as you find a negative sign, you can just raise your hand and say, hey, they will not match. Okay? Are we on the same page? Alright. Now, let's look at another one. This is more with respect to properties of matrices when we are dealing with multiplication of scalars, and that we have already done. We are just trying to consolidate and get a holistic view of the things. Okay. So what we saw was, if I have a metric A, where I'm just picking up easy ones. Okay, it's a 1 by 1 metric. Okay, and 1 by 1 is just too simple to believe. I'm just picking 1 by 2. So the zero metric is always repeated. Let's say if this is A with one row, two columns, equivalent zero metric of that will be written as 0, and you are saying number of rows, number of columns. This is how you can repeat the zero metric. Okay. So here A times 0 will give you a zero metric with 1, 2, or whatever is the dimension of A. This is one interpretation that we can draw. If I am talking about 6 of A, I am essentially talking about multiplying each and every element by number 6. This part is okay. Now, if you want to add more flavor to it, 0, it's not zero metric, I'm saying 0 multiplied by A is equal to 0 multiplied by B. This rule also holds true as long as A and B have matching dimensions. Okay. So these are some of the things that we have to think. Now I want you guys to tell me what is other possibility that you can think of. Let's say if you have A and B metric, what is other derived relationship that you can think of? Anything creative. I mean, we know all the operations. We know how to deal with addition, subtraction of matrices. We know what is a zero metric. We know what is a opposite metric. So these are some of the form. Okay, let me not bother you guys much. What I'm saying is, let me add one more flavor to it. I have 3 matrices now. If I say 0 multiplied by A plus, or if I say this, I have, let's say, 3 matrices. I multiplied by 0, meaning I am multiplying everything by, let me not write it like this, I will write it like this. That will be equal to 0 times A, or 0 times B, or 0 times C. So these are like very simple, stupid definitions that you can derive, simple formulas that you can arrive at, and you'll be surprised to know that when you try doing the unit test in Khan Academy, you'll see that these kind of questions which look very simple in nature, but you will find some of those interesting questions in your ICT exam also. Okay, so these are the things that we wanted to learn today, and we have covered it much ahead of time. I'm just trying to figure out if I can pick up any other topic also. Let me look at it. Let me see if I can pick up the multiplication part today. I mean, I don't want to rush through it, but if that is not very difficult for starting at least. Okay. I'm just thinking if we should start or not. No, I think this will need a little bit more coverage. Okay, let's not rush through it, because we have to learn about some more usage of matrices before we jump to multiplication of matrices. Okay, and you will see a lot more interesting stuff coming your way when we go to multiplication of matrix. So far, whatever we have covered, we'll stick to that. So we have learned the matrices, what are the matrices, then we learned about how do we deal with basic addition, subtraction, what do we mean by dimension of matrix, then we talked about what is what is about adding and subtracting matrices. Then we looked at what are the limitations that we have to deal with, what we can add versus what we cannot add out. Likewise, what we can subtract versus what we cannot. Then we looked at what is zero matrix, and then we also looked at what is opposite matrix. And then we looked at some of the properties where how addition and subtraction plays an important. I mean, what is that we have to keep in mind where addition or subtraction by jumbling the matrices, does it make any difference or not? Similarly, we just looked at some of the properties that comes into play by while we are dealing with multiplication of matrix by scalar quantities. So after this one, the thing that we are going to cover, not today, but let me just read it for you guys. And essentially that would mean we will need how many classes to cover this unit. So we are going to talk about using matrices to manipulate data, matrices as transformation of the plane, using matrices to transform the plane, transforming 3D and 4D vectors and matrices. So this is a loaded chapter, okay? So we'll probably give it probably 3 more classes to finish matrices, and then we'll go to probability and combinations. Combinatories, okay? Let's see what is there. Okay, so basically we have total 10 units. We are on the 7th unit right now, which is matrices, and then we have probability, and then we have series, and then we have units and continuity. That will finish our all the topics that we need to cover from a pre-SAT point of view. If you guys want, we can redo the whole thing from beginning one more time, or if you guys are interested, we can straight away jump to calculus. I'll leave it for you guys, but we still have I see that we have 3 more units after this, so we are going to take another 3.5 months max by the time we finish pre-calculus, and based on how much energy you're left with, or what you guys find more interesting, we'll switch to that. And we'll see if there are new kids also joining the class. So we'll see how we want, if you want to do pre-calculus in the same class, or we want to separate out pre-calculus and calculus classes, based on everybody's preference. Okay. But my recommendation would be, we have skimmed through the pre-calculus concepts so far. We have done one round of it. The way it works best is, I would say we'll do one more round of it. And next time it will be me talking less, you guys doing more practice, and we can focus more on actually solving the problems rather than just learning the concept one more time. So that would be my recommendation, but I will leave it for you guys how you want to do it, or depending on how much practice you are able to do outside the class, and we'll take it on. Alright? So that brings us to the end of the class. I will let you guys go. There were not many questions, and the topic was also not very complicated, but the next 2 classes we should be able to finish matrix part. Is that
Thank
okay?
you, sir.
Alright. Enjoy the rest of your evening, and see you guys next Saturday. Alright?
Right.
Yep, bye bye.
Sir, I had a question
Yeah.
before we go.
Yes, sure.
What was-
One second, madam.